Okay, so here we're going to talk about S1J and S2D, arc length and area of a sector. So there's some vocabulary you should become familiar with. Radius is the distance from the center of the circle to an edge of a circle. A chord. Chord means just any old line that connects two parts of a circle together. So any old line that connects two parts of a circle. So a diameter, for example, is a chord. Okay, minor arc and major arc. So minor, of course, means small, and major is a big thing. So if I've got a length around a circle that's smaller than half of it, it's going to be a minor arc. And a length around the circle that's larger than half of it is called major. Okay, and all the way around the circle, you may want to write this down, this is not on your handout, is called the circumference. Circumference, you should have learned back in geometry. This length around the circle is 2 pi r. Okay, and this formula here you'll be discovering on the next page. We won't be using radians, it's used for HL. Okay, so as we said, the circumference around the circle, the length all the way around the circle is 2 pi r. In our activity that we did today, we realized, look, this picture has a quarter of it taken out. Looks like Pac-Man, Waka Waka. Just kidding. Okay, so I've multiplied this by 3/4 because it's 3/4 of a circle. And then it simplifies to this. This is half of a circle, so I multiplied 2 pi r by half. This is a quarter circle, so I multiplied 2 pi r by a quarter. This here is 1/8 of a circle, so we multiplied it by 1/8. And then at 1 degree, we figure out, how many 1 degrees are there all the way around the circle? And you know the circle is 360, so this is going to be 1 over 360 times 2 pi r, which helped us to come to the conclusion that the formula is equal to the angle over 360 times 2 pi r. It gives us the formula for finding the length around the circle. Okay. So basically, this length here around the circle. Okay. All right, so let's do investigation question number 2. Okay, a window which has a semicircle radius of 12 is divided into 6 congruent parts. Okay, so the radius is 12, right? And so find the length of the arc of the semicircle. So we want to find this length all the way around. Okay, so if it's half of a circle, we know it's going to be pi times r, right? Because all the way around the circle is 2 pi r, so half of that is just going to be pi r. So, so I've got the radius times pi r. Well, the radius is 12, right? There we go. Okay, find the length of the arc of one of the sections. So one of the sections, I'm going to take this full length and I'm going to divide it by 6 because it's 1/6. And then we get this answer. Okay, the next one, if the window is divided into sections of only 1 degree. Okay, so we're going to use the formula for 1 degree, which is 1 over 360 times 2 pi r. And that's going to give me this tiny little length. Okay, then what's the formula? Well, we did this in part 1. And then generate the formula. Well, we've already done that now. We just replace the 12 with r to generate the formula. You may want to hit pause if you need more time. Okay, so now we're just using this general formula which is the length equals the angle divided by 180 times pi r. So for all of these, we've got our angles. And we've got our radius. And you put that into your calculator and you get your answers. You may want to hit pause to check your work. Okay, number 2, we've got a clock. Okay, so and they gave you the diameter of the circle, and they said what is the length of the arc from 12 all the way to 5. Okay, so 12 all the way to 5, this is going to give me 5/12 fraction of the circumference, and all the way around the circle is 2 pi r, right? So we know the radius is 12.5. How do I get that answer? Well, the diameter is 25, so the radius is half of the diameter. So using the 12.5 radius and the 5/12 fraction of the circle, we're going to get this length. You may want to hit pause to think about this. Okay, area of the circle is the area of this part here. You may want to write this down. Area of a circle is pi r squared. You should have learned that in geometry. And our formula for finding the fraction of the area of the circle, we're going to use the same ratio as the angle over 360, like we did on the previous page. The same ratio. Area equals the angle over 360. This is our fraction of the circle, pi r squared. Okay, so here you're told that the angle is 120, and you're told the radius is 5, so you're simply just plugging in 120 and the 5, and then you get your answer. You may want to hit pause to check your work. Okay, next page. Okay, this is slightly different. They've given you the area is 30 pi, and they've told you the radius is 13. So in order to figure this out for the angle, we have to multiply both sides by 360. That gets rid of the 360 denominator. And now to find theta, we're going to divide both sides by pi and 169. 169 is 13 squared. And so when we divide this by this, then we end up, the pi is going to cancel out, and then we end up with 63.9 degrees. You may want to hit pause to check your answers. Okay. On these questions, we simply plugged in the angle and we plugged in the radius. Check your answers. Same thing here. Okay. Question B and C are a little bit different. You're trying to find the angle here, and here you're trying to find the radius. So what did we do? Here the angle, the area is theta over 360 times pi r squared. We plugged in our 10 centimeters squared here. We had our area here. So step 1, I multiplied both sides by 360 to get this line, and then to get the next line, we divided both sides by 100 pi, and then that simplifies to this. Okay, on this one here, we put in 8 pi for the area, and we put in 50 degrees for the angle, and now we're trying to find r. So I multiplied 360 on both sides to get this line. The pi's cancel out, and then I get the 2,880 divided by 50 is going to give me this. And now to find r, I've got to take the square root of 57.6, and we get our answer in 3 significant figures. So check your work, and I hope this makes sense.